Greetings and welcome back to the SpaceX front page. This is an analytical and comprehensive, succinct report on the launch of Integrated Flight 3 of Starship by Space Explorations. Buckle up for the facts. This report is based on the third test flight IFT3 of SpaceX's Starship rocket. The launch proceeded on March 15, 2024, reached its planned orbit, and then achieved its first entry into space. Starship's full-stack launch number 3 surpassed the previous test flights. The flight also included a hot stage separation with the booster rocket and reached orbital velocity. Here are some analytical details about the flight. The launch pad had 4 locked subcoolers and 2 pumps, and 2 liquid methane LCH4 subcoolers and 1 pump. This reduced propellant loading time from 97 minutes to 50 minutes. The rocket reached an altitude of about 145 miles, 233 kilometers, as it coasted across the Atlantic in South Africa before approaching the Indian Ocean. The rocket broke apart before the flight was complete, but officials celebrated the launch, calling it successful. In dedicated stage analysis. Firstly, Super Heavy. Engines. All 33 Raptor booster engines stayed lit through stage separation, an improvement from Integrated Flight Test 1, which had several flameouts during its booster ascent. Integrated Flight Test 1 booster did not make it to this stage. Hot staging. Separation was successful, sending the second stage to space and protecting the booster enough for it to complete its flip maneuver and boost back burn. Integrate Flight Test 2 booster exploded, though some may prefer stating this to have been an ordered mission abort, not so much of an explosion, shortly after hot staging. Super Heavy booster rip. The booster successfully relit several engines for the landing burn. However, the mega vehicle came in too hot and wobbly, eventually ending in a fireball 462 meters above the Gulf of Mexico. Secondly, Starship's second stage. Starship's second stage achieved orbital velocity, albeit on a planned suborbital trajectory. In Integrated Flight Test 2, Starship broke apart just short of orbital velocity. In the third launch, the second stage reached semi-orbital status. Open door. While enjoying the beautiful views of Earth in cruise mode, SpaceX completed an open and close test of the payload door. Prop transfer. SpaceX initiated a propellant transfer demonstration as it aimed to move possibly 10 metric tons of cold liquid oxygen propellant from one tank to another for a NASA tipping point contract. Flaps. Upon atmospheric re-entry, Starship's flaps gave us a couple of big friendly walrus waves as they adjusted the vehicle's orientation. No in-orbit burn. SpaceX elected to forego its in-space engine burn due to vehicle roll rates during coast. Starship rip. Starship re-entered the atmosphere at hypersonic speeds, creating a surreal scene of fiery plasma build up around the vehicle. The journey ended 49 minutes into flight when the vehicle lost telemetry and likely broke up due to the hellscape re-entry environment. SpaceX's third test flight of the massive Starship rocket, which NASA plans to use to return humans to the moon, ended the same as the first two, with the oversized vehicles breaking up before the flight was complete, but officials are celebrating the launch, calling it successful. That might sound like a curious description to some people given the complete loss of the rocket, but at this stage, success doesn't have to mean a picture-perfect landing. In this case, it meant that the vehicle was able to achieve most of its goals during its short flight. For instance, Starship was able to reach orbital velocity, and while the spacecraft was empty, had it been carrying cargo on board, it would have been able to successfully deploy that, as the craft was able to both open and close the payload doors. It also completed a fuel transfer demonstration, a process similar to the aerial refueling the military does with fighter planes. The total flight time for the journey was almost 1 hour, which is considerably longer than the first 2 flights. If Ship 28 re-enters successfully and splashes down in the Indian Ocean in one piece, and Booster 10 completes its landing burn, finally, if no anomalies or property damage occurred, SpaceX will not be required to complete a mishap investigation as defined in Federal Aviation Regulations Part 451-173. But if there is an anomaly, then SpaceX will have to perform a mishap investigation just like the last 2 flights. After Flight 3, there is Flight 4, which is currently slated to be Ship 29 and Booster 11. Now, Ship 29 has already completed a spin prime before being rolled back to the production site, and Booster 11 is patiently waiting its turn to have the OLM. It's going to be very interesting to see how quickly Flight 4's test campaign will be and how quickly it will be ready for launch. The Starship Integrated Flight Test 4 launch report indicates that the launch was more successful than the previous one, and the mishap report will likely be easier. The launch also reached orbital speed for the first time in a historic test flight from South Texas. SpaceX's Starship rocket is the world's largest and most powerful rocket. NASA plans to use it as part of its mission to return astronauts to the moon. According to SpaceX's plan, Starship could carry 100 people into orbit at once. Ultimately, SpaceX lost both vehicles in descent, thereby triggering an FAA mishap investigation and putting any future flights on a temporary hold. Open quote. A mishap occurred during the SpaceX Starship Integrated Launch No. 3 mission that launched from Boca Chica, Texas on March 14, said the FAA. The mishap involved both the Super Heavy booster and the Starship vehicle. End quote. Going forward, there's still considerable learning ahead in booster landing, heat shield tiles, vehicle control, and re-entry maneuvers. In line with its philosophy of rapid iteration, the company has several vehicles ready and waiting for another attempt. Starship IFT3 Integrated Flight Test 3 marks a significant milestone in the development of SpaceX's Starship spacecraft, conducted with the goal of advancing the technology necessary for future space exploration. This mission aims to validate critical systems and procedures required for safe and efficient space travel. Regarding the purpose of this mission, the primary objectives of Starship Integrated Flight Test 3 are as follows. 1. Test the performance of the Starship spacecraft in an operational environment. 2. Validate the functionality of key systems, including propulsion, avionics, and thermal management. 3. Demonstrate the ability to conduct a controlled re-entry and landing maneuver. 4. Gather data to inform future design iterations and improvements. Regarding the mission procedure, this is the breakdown. Firstly, there are pre-launch preparations. Several weeks before the scheduled launch date, SpaceX engineers conduct thorough checks and inspections of the Starship spacecraft to ensure all systems are functioning nominally. Final integration of payloads and fueling operations are carried out at the launch site. 2. Secondly, there is the launch countdown. A launch countdown begins approximately 48 hours before the scheduled liftoff time. During this period, the spacecraft undergoes final preparations, including fueling, system checks, and payload integration. Mission controllers monitor weather conditions and other external factors that could impact the launch. 3. Third procedure is liftoff. At the designated liftoff time, the Starship spacecraft ignites its Raptor engines and lifts off from the launch pad. Mission controllers closely monitor the spacecraft's trajectory and performance during ascent to ensure a nominal flight profile. 4. Fourth procedure is in-flight operations. Once in orbit, the Starship spacecraft conducts various in-flight operations to test its systems and capabilities. These operations may include engine burns to adjust orbit, deployment of experimental payloads, and other maneuvers to simulate real-world mission scenarios. 5. Fifth stage of mission operation constitutes the re-entry and landing phase. After completing its mission objectives in orbit, the Starship spacecraft begins its descent back to Earth. The spacecraft performs a series of control maneuvers to orient itself for re-entry into the Earth's atmosphere. Thermal protection systems are activated to withstand the intense heat generated during re-entry. As the spacecraft approaches the designated landing site, its engines reignite to slow its descent and facilitate a soft landing. Mission controllers closely monitor the landing sequence and provide real-time guidance to ensure a safe touchdown. 6. Sixth-stage post-launch are the investigative and post-mission operations. Following a successful landing, recovery teams are deployed to secure the spacecraft and prepare it for transport back to the launch site. Data collected during the mission is analyzed by SpaceX engineers to evaluate the performance of the spacecraft and identify areas for improvement. Lessons learned from the mission are incorporated into future design iterations of the Starship spacecraft. The successful launch and completion of Starship Integrated Flight Test 3 represent a significant step forward in the development of SpaceX's Starship spacecraft. By demonstrating the capability to conduct complex in-flight operations and safely return to Earth, this mission brings humanity one step closer to realizing the vision of interplanetary space travel. As SpaceX continues to refine the design and functionality of the Starship spacecraft, future missions will build upon the successes of the Integrated Flight Test 3 to further advance the frontiers of space exploration. This has been a Space Exploration Front Page Report. Thank you for choosing us as your source of reliable space explorations reports. Come back for more. As always, like, subscribe, and leave a comment down below. We do read all comments and extensively address any questions regarding the mission. Until we meet again, bon voyage.